Welcome to one and all. He's Arvind Rajan, Shamlan and myself Sridhar. We are the students of Edtech Dr. R.M. Dr. S.R. University and we are doing our final year BTech IT. We are doing a project on optimization of uplink query processing using relay nodes. Now we are going to show how our project working.
Uplink denotes the path from the mobile station to the application server, whereas the query processing denotes the reduction of queries from the mobile station to the application server.
We have lot of application in mobile. Each application retrieve content from remote server via user generated queries. But processing the request on the mobile device involves sapping of limited battery resources. Conversely, if the processing is done at remote server, it involves communication latency. To overcome the communication latency and battery usage, we will use mid-nodes processing through leasing server. However, borrowing processing power from mid-nodes involves a cost due to leasing servers at mid-nodes and allocating memory for caching. Here, our main aim is to study the trade-off between battery usage, processing and transmission latency through the help of dynamic programming framework.
Applying optimal processing policies to distribute the amount of processing over mid-network nodes in order to reduce the query size, leasing costs, communication latency and battery drainage. Existing system says about the user request is generated at the mobile station will be processed at the mobile and gets passed to the application server via base station and relay nodes, and the content is sent back to mobile station. Clicking image involves feature extraction and similar other processes which takes place at mobile station. The main drawback in the existing system is increasing battery usage will decrease latency and also limits the lifetime of the mobile. The proposed system we propose says that there are number of systems which enable distributed processing across multiple nodes. We consider systems with leasing servers which are deployed at mid-network nodes to offer processing capability for the user queries before they reach the application server. Deployment of intermediate node cache, they process queries for data and respond with content if they have it. The main advantage of our proposed system is elevate the processing burden on the mobile station, thereby reducing its battery consumption and extending its operational lifetime. Leasing processing power from mid-network nodes can help lower communication latency because rather than transmitting the entire large request message over multiple congested links to the application server, mid-network processing will reduce the message size.
This is our architecture. In this architecture, we have divided this network into two portions. One is between mobile station and base station. Another one is between base station and application. The link between mobile station and base station is wireless, and the link between base station and application station may be wired or wireless. Within base station and application, we have a lot of nodes. Now our problem is the bandwidth between mobile station and base station is very much constrained. Lot of mobile application generated the same queries to base station, which resulted in congestion. To overcome the congestion, we have to reduce the query size from each and every mobile. This is the main aim of. We can't overcome the battery drainage and communication latency by leasing servers at bit nodes and allocate correct amount of processing to each node through dynamic programming algorithm. This is our conclusion of the project. I am now going to show my project demo. First, we should get the IP address. Then this IP address should be entered in corresponding text box. Here our IP address is 123.236.78.174. Then you should enable the text area in order to enable the typing screen. Here you are typing the message whatever you like. Here I am typing the message as hi friend, how are you, followed by this is my text to audio converter. Having done that, now we will going to click the convert to audio button. You can see the status at the bottom of the screen. The status will show the network condition. Here the file is successfully transferred. After that, you can see the path from source to destination is displayed in the right panel. Now you are seeing this. After that, we have come to application server window. In this window, you can see the message what you have typed. Click on the save button and save the file in the desired format in audio file. We can't overcome the battery drainage and communication latency by leasing servers with nodes and allocate correct amount of processing to each node through dynamic programming algorithm. This is our conclusion of the project.